Right. So now we're going to look at graphing a quadratic. You remember a quadratic, it's either U-shaped or N-shaped. And we're going to talk about all of the features of the quadratic equation. So the first thing you want to do in your graphing quadratic is you want to get it, if we got it in standard form, you want to write it from highest power to lowest power. So I'm going to re-express this as f of x equals, I'm going to put the highest power first, negative 4x squared minus 12x minus 3. So from highest power to lowest power. Now, what are a, b, and c, those coefficients? A is the coefficient of x squared, so a is negative 4, so a is the number in front of x squared. B is the number in front of x, and then c is this constant. Okay? Now, next, I'm going to find the axis of symmetry. So how do I find the axis of symmetry? It's pretty simple. There's a formula. It's x equals negative b divided by 2a. So I'm going to plug those values into my equation. Negative times negative 12 divided by 2a. You got to be careful with all these negatives in here. And negative times negative 12 is positive 12 divided by 2 times negative 4 would be negative 8. So x is equal to negative, divide each of those by 4, negative 3 halves. Okay, so there's my axis of symmetry. And when you do your axis of symmetry, it's always x equals a number, and you're going to see why. It's going to be this basically imaginary line that's going to cut your parabola or your graph in half. Okay? So how do I find the vertex? I plug this in. I plug in the x from the axis of symmetry into my function. So I'm going to go f of negative 3 halves equals negative 4 times negative 3 halves squared minus 12 times negative 3 halves minus 3. So the vertex of the point. And so what I'm doing right now is I'm finding the y for my point here. And this plugging in the axis of symmetry, which is the center, basically this where the line gets cut in half, or the parabola gets cut in half. By finding this value, now I could find out where my y is going to be at that point. Okay, so it'd be 6. So my vertex is going to be negative 3 halves, comma 6. So that's going to be the point, basically kind of my middle point. The y-intercept, all the y-intercept is, it's just the last number. It's the constant term in standard form. So the y-intercept is 0, negative 3. It's just the constant term. Okay. Now, we'll get to all this here in a moment. Let's go ahead and start graphing. I'm going to skip ahead a little bit. So my center of my graph is going to be this negative 3 halves. So I'm going to make a table. Negative 3 halves is going to be the center, which is negative 1.5. So I got to think of what are two numbers that come before negative 1.5 and that come after negative 1.5 I could use. So I would say negative 2 and negative 3 come before it, will come after it, negative 1 and 0. So I'm going to plug those values into my function to find the corresponding y. So negative 4 times negative 3 squared minus 12 times negative 3 minus 3. Negative 4 times negative 2 squared minus 12 times negative 2 minus 3. I've already done this one. Negative 4 times negative 3 halves squared minus 12 times negative 3 halves minus 3. That's going to be 6. Okay, negative 4 times negative 1 squared minus 12 times negative 1 minus 3. And so I'm just plugging in these x values into my function to find the y. So I could go back up here. I'm actually going to, I'll do it again. Negative 4 times negative 3 squared minus 12 times negative 3 minus 3. So it's negative 3. We'll go up here and press enter, press up, press enter, and we'll change the negative 3s to negative 2s. So I get 5. Okay. And I know what negative 3 halves is. So I'll go to negative 1, 5, and then 0. Okay. That's negative 3. Okay. Now, if I'm doing this right, you should see some symmetry here. Okay, these two should be the same. These two should be the same. Okay, so if I'm doing it, picking the points right after that, that would be helpful there. So now I'm going to plot these points. So I've got -3, -3. I've got -2 and 5. Okay. I've got -3 halves and 6. So -3 halves, so -1.5 and 6. -1 and 5 and 0 and -3. So there's my graph, and then I can start connecting this. I'm going to do rounded around the corner there. So that's not the prettiest graph you've ever seen, but there's my parabola. They call it quadratic graph. They call this a parabola. So that gives you an idea of what's going on here. Now, does this graph have a maximum or a minimum? This graph has a maximum. Okay, it's a high point. Is it concave up or concave down? Is it caving upward? Like caving upward, concave up is like this. Concave down is like this. It's concave down. Okay. Domain and range. Let's talk about that. So domain, how far left does this graph go? Well, it goes forever to the left. So negative infinity. How far right does it go? It goes forever to the right. So it'd be infinity. Range. How far down does it go? Remember, how far down to how far up? How far down does it go? Negative infinity. How far up does it go? Well, it goes up to 6. Okay. Zeros, the x-intercepts. So they don't appear to be exact. So maybe around maybe -2.8 and 0, and maybe -0.2 and 0. Like, just it's between -3 and -2, closer to -3. It's between -1 and 0, closer to negative or closer to 0. So those are estimates. They're not exact. I'm just kind of getting you zeros are where it crosses or touches the x-axis. So we're going to learn a lot about that throughout this class. I'm introducing it to you today. But zeros are where it crosses or touches the x-axis. You don't have to put, that's just approximately. You don't have to put those there, but that describes that. So that's basically graphing a quadratic function in standard form using a table. And remember, in linear, using a table is not time efficient, but when you have more complex graphs like a quadratic or cubic, all that, tables can be very helpful.